In this video, let's try to solve a simple problem that involves computation. Say, the 8-digit ID numbers in a certain university can be verified by multiplying the first digit by 8, the second digit by 7, and so on, until the last digit is multiplied by 1. Then the sum of the series of products should be divisible by 11. Otherwise, the ID number is fake. For example, if you have 111911031 as the ID number, then if you are going to multiply the digits by 8, 7, and so on, as exemplified here, you will get a sum of 77. Since the number 77 is divisible by 11, then the ID is valid. Otherwise, if you have, say, 111911013, and you multiplied it with 8, 7, and so on, you will get 75. Since the number 75 is not divisible by 11, the ID is fake. So the problem states that design an algorithm for the verification of ID number for that particular university. So give the pseudocode of your algorithm and sample run. So first off, let's examine the possible inputs of our algorithm. So let's search for it. Here the input is an ID number, and we could consider it as an array or directly consider it as an integer, whichever is easier for that particular algorithm. Say, let's give the algorithm a name. Say I want this algorithm to be ID verification, or maybe ID verify. Input argument is simply could be an integer for the number. So we have int ID. Say ID number. And that is our input. So our input is an ID number. And we will simply consider this as an integer, although it cannot be negative. Integer, and in particular this is an 8-digit positive number. And our output will be either true or false. So the output is the validity. Which is either true or false. So it's a Boolean output. So the operation is we'll simply get the total of its product with 8, 7, until 1. One way of going around this is just repeatedly computing the modulo of the number. Say we initialize a sum to be 0, and after that we're going to repeat a for loop, say for I index from say 1 to 8, 1 up to 8. We will repeatedly perform, say, update of our sum. So update the sum with the products. So we'll go with the smallest. So we could derive the smallest, the units digit, for example, by getting the modulo of the input number, say modulo of the ID, with 10, and we will simply multiply this with our I. And pretty much that's it. So after this, we're going to update the ID number. So we're going to repeatedly divide this by 10. And end the for loop for the modulo check. Then if sum modulo 11 is equals to 0, then we return true. True. Else return false. That's it. So let's try to implement this pseudocode. So if we have let's just make it an int and ID verify. So ID verify. And input arguments is simply the ID number. And we're going to initialize a sum. And the for loop. So the for loop will start with 1 less than or equal to 8. Update the I. And then after that we will update the sum with the ID number modulo. So ID number modulo 10 and multiply this by I, and after that we will simply get the updated ID number, which will be ID number over, so this is the integer division with 10. And afterwards we're going to perform the final comparison. So if the if the sum modulo 11 is equals to 0, then let's return 1 or true, else return 0. And we're just using 1 or 0 here because C doesn't have a Boolean data type, so that we are returning 1 for true. So this is for truth, and 0 for falsehood. Okay, so let's try to test this one. ID number, say let's ask for an ID number. Say put string, or let's declare an int ID number, and let's ask for it. So enter your ID number. We are going to scan that and put it to our ID number. Let's minimize the pseudocode for now. Wait. Enter your ID number and let's scan it. ID number, and let's have a simple if else. So if, let's verify ID verify, let's call the ID verify. Say if ID verify and ID number. So if ID verify ID number, then let's have ID is valid. The ID number is valid, else it's not valid. Say your ID number is fake. And that's it. So let's try to run it with the example. So we have an example of 111911031. So this is a valid number. And let's recall the algorithm again. So it's initialize the sum and repeatedly gets the remainder with 10, multiply it by 1, the first number, and get the total. The next remainder will be multiplied by 2, and so on until the last one will be multiplied by 8. And once the sum is solved, then we are going to get the modulo with 11 for the final check and return true if it's if the modulo is 0 or it's divisible by 11. Otherwise, we are going to return false or 0. So that is the algorithm. Let's verify this by running the code. Okay, so we are now running the program. So let's input an ID number of 111-91031, and we will get the ID number is valid. Okay, how about let's print the sum, so we have an idea whether it is computing the actual sum. So printf the sum is just for us to get an idea. So let's run this again. Same input. So I'm expecting a sum of 77. One 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 91031. Okay, 9 is valid. How about the other number? So the other number is 111-91013. So we have 111-91013. And if we enter this, so the sum is 75, the ID number is fake. So somehow we have shown that for these inputs it works. So that's it. For the pseudocode, we have the solution. So for the ID verification, so we have just one simple for loop and a final comparison for the divisibility by 11.